Okay, Waka, today we're looking at journal page 13, inverse of quadratic and square root functions. Example 1, find the inverse function f inverse of x for f of x. F of x equals parentheses x plus 2 squared minus 3. So step 1 is really just to identify the functions. We have f of x equals x plus 2 squared minus 3. It's really just looking at identifying that it's a quadratic parent function and that it's going to have some transformations, okay? All right, so step 2, you're going to change f of x to y. Okay, step 3, because we're doing an inverse, we're going to switch x and y. So x equals y plus 2 squared minus 3. Okay, and then step 4 is we're going to resolve for y, or solve for y. Okay, so we're going to add 3 to both sides. X plus 3 equals parentheses y plus 2 squared. Okay, then we're going to take the square root of both sides. Okay, and let me show you what when you take the square root of that happens. So now to understand that first, understand that this, oh wait. So 2 there, okay? So this is, let's make sure I write this correctly. When you say square root, that's technically to the 1/2 power, okay? So this is to the 1/2 power. And the reason why that's important is because now, if you whenever you have an exponent to the power, you multiply. So this becomes y plus 2 to the 2 divided by 2, which equals y plus 2 to the first power, which can be written as just y plus 2. Okay? All right. So now we're left with the square root of x plus 3 equals y plus 2. We're going to subtract 2 from both sides. So then you get the square root of x plus 3 minus 2 equals y. Now that's acceptable, okay? But you want to write this as f inverse of x equals the square root of x plus 3 minus 2. Now, this is fine, but you can also write this as -2 plus square root of x plus 3. And the reason why I'd recommend writing that sometimes is if you have trouble with accidentally putting this under the square root, if you put it in front, you don't have that problem, okay? All right, so finish up that part of example 1. All right, now example 1 continued. Let's graph. Now we're going to start by graphing f of x. Now I don't think we have room on this paper, so I'm going to use a note card to make that table. Okay. Now remember, f of x equals x plus 2 squared minus 3. Now, let's start our first point of the transformation. So this tells you move the graph left 2, down 3. Okay. Now, we know the parent function starts at the origin. So in the transformation, we transform from the origin. So from here, we go left 2, down 1, 2, 3. And that's our first point. So that's negative 2, negative 3. Okay? So let's evaluate the function at that. So when x is negative 2, that's negative 2 plus 2 squared minus 3. Well, that's 0 minus 3, which is this negative 3. Okay? So that's our first point. Now, it'd be logical to use negative 1, because that's the next point. Let's see if that works. So negative 1 plus 2 squared minus 3. Well, negative 1 plus 2 is 1. 1 squared is 1. So 1 minus 3 is negative 2. Okay, next point, 0. So then that's 0 plus 2 squared minus 3. Well, 2 squared is 4. 4 minus 3 is 1. And let's go one more point. Let's go when x is 1. So that's 1 plus 2 squared minus 3. Well, 3 squared is 9. 9 minus 3 is 6. And if you want to check, you can use Desmos or a calculator to plug those in. You'll see that those values line up. Okay. All right, so let's graph these points. So negative 2, negative 3. So negative 1, negative 1, negative 2. 0, 1. And then 1, 1, 2, 3, 4, 5, 6. Okay. Now, one thing special about when you're doing inverses with the quadratic is you only graph the positive side of the graph. Okay. Normally there's this portion of the quadratic, but we ignore that when we're working with inverses of quadratics. Okay. You'll notice I've graphed the f of x equals x line. Okay. So now, real simple to get the inverse, which is negative 2 plus the square root of x plus 3. Remember, inverses switches x and y. So all we have to do is switch the x and y in this table and graph the points. So our new x values are negative 3, negative 2, 1, 6. And then negative 2, negative 1, 0, 1. Okay? So let's graph those points. And actually, let's graph those in yellow. Okay? So the point is negative 1, 2, 3, negative 2, negative 2, negative 1, 1, 0, and then 1, 2, 3, 4, 5, 6, up 1. Now, why the f of x equals x line is important is because if these are inverses, they reflect over the f of x equals x line. And they do, so you can see these inverses. And you can also see that here, the inverse of a quadratic is square root, and the square root is only half of the u shape, and that's why we only graph half of the u shape in the quadratic. Okay? So if you would, go ahead and finish up example 1, and I'm actually going to just tape this note card here to the page so I have it later. Okay? All right, let's move on to the next portion. All right. Journal page 13, inverse of quadratic and square root functions continued. Example 2. Find the inverse function f inverse of x for f of x. F of x equals the square root of x minus 1 plus 2. Okay, so step 1, we're just going to basically look at the function where it's seeing that this is the square root. Now, if the plus 2 on the outside throws you off, you can always write this as 2 plus the square root of x minus 1. Again, that way you don't confuse it for being accidentally under the square root. Okay. All right, step 2, we're going to change f of x to y. Well, it just looks ugly. I'm sorry, that might not bother you, but it's bothering me right now. Let me like to line these up so they look nice. Y equals 2 plus the square root of x minus 1. That looks much better. Okay, now step 3, we're going to switch x and y. So x equals the square root of y minus 1 plus 2. So you're going to switch x and y. Man, that's just, I'm looking at my screen. It looks over here, it looks a little messy. So I'm going to clear that up just in case some of you are having trouble reading that. Okay, and then step 4, okay, solve for y. All right, so then we're going to subtract 2 from both sides. So you have x minus 2 equals the square root of y minus 1. And then you're going to do the opposite square root of square. So we're going to square both sides. Okay, so then you get x minus 2 squared. This becomes y minus 1. And then we add 1 to both sides. So you have x minus 2 squared plus 1. And you can leave the plus 1 there because it's obvious outside of the parentheses equals y. So you have f inverse of x equals x minus 2 squared plus 1. All right, go ahead and finish up the first part of example 2. All right, so now let's graph, okay? So again, I don't think we have room. So let's use a note card. I'm just going to make a table real quick on this note card. I'm going to start with f of x, which we know is equal to the square root of x minus 1 plus 2. Now, picking our first value is pretty simple in that you can't have a negative under the square root. So the first value would be 1 because 1 minus 1 is 0. So the first value is going to be x is 1. Okay, so then that's the square root of 1 minus 1 plus 2. which is 0 plus 2, which is just 2. Okay? Now let's use x as 2. So then that's the square root of 2 minus 1 plus 2. Well, 2 minus 1 is 1. The square root of 1 is 1 plus 2 is 3. Okay? Now, we're not going to use 3 because 3 minus 1 is 2. That doesn't work. We need something that can take the square root of. So we're going to use x equals 5 next. And I'll show you why. Okay, square root of 5 minus 1 plus 2. Well, 5 minus 1 is 4. Square root of 4 is 2. 2 plus 2 is 4. Okay. And then let's do one more value. Let's use 10. So the square root of 10 minus 1 plus 2. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. Okay, so let's graph those points. So 1, up 1, 2. Okay. 2, 1, 2, 3. Okay, and then 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. And then 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Okay, and again, you see that I have f of x equals x graphed. All right, now, real simple for the inverse. All we have to do is switch the x and y values. So then that's 2, 3, 4, 5. And then 1, 2, 5, 10. Okay, and we're going to do that in yellow. Okay, so our first point is 2, 1, 3, 2. So 1, 2, 3, 1, 2. And then 4, 5, 1, 2, 3, 4. See, 4 and 1, 2, 3, 4, 5. And then 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you see here they reflect over the f of x equals x line. So they are inverses. Let's attach this. When you're done, don't forget to work for about 15 minutes on the Khan Academy SAT prep, and have a wonderful Wildcat day.